Hey guys, and welcome to your first challenge episode. Today we're going to be making a combat simulator. It's not quite a game, it's just going to simulate a combat between two armies. So the way these challenge episodes work is first I'm going to describe to you the game you are going to make. I'm going to show you some diagrams or something, or show you an example, and then what you're going to do is pause the video and go off and try to create the game all by yourself. If you get stuck, all you have to do is unpause the video, and I'm going to be giving you some hints. Today I'm going to give you 3 hints. Then you're going to pause the video again and try one last time to try to make the game. I want you to try as hard as you can. Use Google if you get stuck. Go back and refer to the other videos. Doing it on your own and really thinking about things and getting stuck and solving it by yourself is how you become a good programmer. So that's what these episodes are for. Now, if you're still stuck and you just can't figure it out after your second try, then all you got to do is unpause the video and I'm going to walk you through a solution line by line. Now, you don't have to do what I do. In fact, I encourage you to do something different. I encourage you to do something better. I'm going to just show you kind of a bare minimum approach to doing these little games, but you could totally take this thing and make a full little combat simulator game out of it. You could go completely overboard, and that is really good. That is how you get good at programming. You go overboard with these things, and you really try your hardest. So first, let me describe to you the game that we're going to make. This is a 1D combat simulator. It's not going to be super exciting, but the way we're going to set this up is we have 2 armies that are facing off against each other. I chose humans versus skeletons. You could do whatever you want. You could say Spartans versus ninjas or something, pirates versus ninjas, whatever. You're going to make your own game, so you're going to define everything yourself. You can give attack values and health values to them. If you want, you can even go as far as using defense values. I'm pretty sure the only thing I used in my example was attack and health. 2 very simple variables. The attack variable is the chance of hitting, and the health variable is just how much health you have. Oh, and then a damage variable. That determines how much damage you do when you attack. All of your units will have the same properties, right? All of the skeletons are going to have the same attack as all the other skeletons. All the humans are going to have the same attack as all the other humans, so it should be pretty straightforward. Now, the way the combat works is since this is 1D, they can only fight each other one at a time because, everybody else is in the way. So what we're going to do is say, okay, this human is fighting this skeleton. Now, if the human wins and the skeleton dies because they keep beating on each other, then this skeleton dies, then the rest come forward and they fight each other, right? And it keeps going until all of one of the armies is dead, and after that we're going to say, yay, there's 2 humans left, we're going to print out some information, we're going to say this many skeletons died, this many humans died, or something like that. Now, we're not using any graphics, we haven't learned graphics yet, that's going to come later. So all you have to do is basically store values. You could do something like store the number of humans and store the number of skeletons, and then each time a skeleton dies, you subtract 1 from the number of skeletons. It's going to be super simple stuff. I'm sure you guys can figure it out on your own, but of course if you can't, I'm going to help you. So let me go ahead and show you an example program. So here's the code if you want to copy it. Haha, it's too small. So let's go ahead and run it, and let me zoom in here so you can see. So here's my example program. I'm going to completely rewrite this, but first what it asks you to do is input the number of humans. So let's say 500 humans. That's quite a few. Now input the number of skeletons. Now my skeletons are much weaker than the humans. They have a lower attack, they're not very strong, so they don't do as much damage, and they have less health. So I'm going to say 3,000 skeletons. Alright, I hit enter and it says beginning combat, then it says combat noises, and it says combat ended, and the skeletons won this time. There are 490 skeletons left, and then we get the casualty report. 500 humans died, and 2,500 skeletons died. So I guess I put way too many skeletons. Those 500 humans were just overwhelmed by those 300 skeletons, and they all died. Now if I run it again, I'm going to get a completely different output. So let's hit run again. Let's do 500 humans again, and 3,000 skeletons again. Skeletons won again. This time there's 490 skeletons left. I guess that's pretty close to what it was. But, you can get a different output each time if you, you know why? I didn't seed the random number generator. So yes, remember to seed your random number generator. Anyways, that's my poor example. So now it's up to you to go make this game all by yourself, remembering to seed your random number generator so it's different each time. So what you want to go ahead and do now is pause the video. Here's the hints. Whenever you are stuck, just unpause the video and I'm going to show you the hints. Starting now. Okay, so if you unpause the video, that means you are stuck and you need a little bit of help. So let's see what the hints are. Number 1, you will need to store the attributes for your combatants in variables. If you're storing an integer value like the number of creatures, use an int. If you're storing a floating value like the chance of a hit, use a float. So at the top of your program, right inside int main, you're going to want to type a bunch of variables. You're going to want to type, some variables for the attack of the skeletons, some variables for attack of the humans, or Spartans, or pirates, or whatever you're wanting to use. And you're going to need to use these variables later in your program. Number 2, you will need a while loop that keeps going until one of the armies has no more troops. After that, the while loop ends and you print out the results of the battle. If you don't use a loop, you're not going to be able to simulate the game. The while loop is really, really important, and you're not going to want to use a for loop because you don't know the exact amount of times that the loop needs to go. With a while loop, what you can do is actually use a condition of while skeletons is not equal to 0 and while humans is not equal to 0, or something like that. As long as those conditions are true, it's going to keep going and they're going to keep fighting. Number 3, you will need a default rand engine to generate random numbers for attacking. Remember to seed it because obviously I forgot. I would recommend using uniform real distribution float attack from 0 to 1 to simulate an attack roll. So remember, you're going to use this variable right here to do your attack roll, and you're going to type attack, and then inside parentheses you're going to use your rand engine to simulate an attack. And then you're going to want to use that with an if statement to see if a creature hit the other creature. Now, I would say whenever you're doing your while loop, you would want the creatures to attack one at a time. You could do random order. You could say humans always go first. You can do this however you want. I'm going to do it my own way. You can do it your own way. It really doesn't matter as long as you fulfill the basic requirements. Okay, so now you should pause the video and try again. Okay, if you unpause the video, it means either you solved it and you want to see my implementation, or you're stuck and you want to see my implementation. So I'm going to go ahead and walk through this thing. Let's open up tutorial videos. Now I have a blank slate. I forgot to mention that you should probably start with a blank slate, but that's okay. So the first thing we want to do is include IOStream, right? Just like we always have had. I'm sure you've probably kept this at the top of your page so you didn't have to remember. But it's good to always delete everything when you make a new program so that you can remember. And then let's have our int main and then the body of our function. So here's where all of our code is going to go. Okay, so my game is skeletons versus humans. So let's do a cout statement, and we're going to say skeletons versus humans. Okay, here's our little title. That's going to look super pretty for whenever people play our game. Now, we need to actually define what the heck is a skeleton and what the heck is a human, right? We need to give them some properties. Oh, look, I forgot something. Identified or cout is undefined. That's what happens if you forget using namespace std, because it doesn't know where cout is. It's in the standard library. Always remember to do that. So we're going to cout skeletons versus humans, but we need some properties. We need to know, okay, how much attack does a skeleton have? How much attack does a human have? So let's make some variables, and I'm going to use floats. I'm going to say float human attack, and we're going to say this is the chance of a human hitting a skeleton. So I'm going to say it's 60%, and 60% would be 0.6f if we're generating numbers between 0 and 1. So now I need a human health variable, right? Because he needs to have a certain HP. Float human health, and for this I'm going to say he has 250 health. That's pretty arbitrary. We could always change it later. We'll just start with something good for now. Next, I need what do I have? I have human attack, I have human health, and I need human damage. So this is how much damage he does when he strikes a skeleton. So we're going to say float human damage. Well, humans are pretty strong, so I'm going to say he can do 200 damage. So he could almost kill another human in one hit. Now I need the skeleton properties, and I can pretty much use these same things except for a skeleton. So we'll say float skeleton attack equals, now the skeleton is kind of weak and he's not very accurate, so we're going to give him only a 20% chance of attacking. And let's give the skeleton some health. Skeleton health. Now 250 is much too high for a skeleton. He's just bones. He doesn't even have any muscle. So we're going to say he has 50 health. And then we need float skeleton damage. And let's say skeleton damage is something like, I don't know, 40, something pretty small. So as you can see, skeletons are much weaker than humans. I think they're actually weaker in this simulation than in my other one. And let's be sure to use comments. So these are our human properties, and these are our skeleton properties. Okay, so now we know what a human is and we know what a skeleton is, but how many humans are there and how many skeletons are there? Well, in my program, I basically just got that input from the user, so that's what we're going to do. So what we need is two variables to store the number of skeletons and the number of humans. So I'm going to say int num skeletons because you can count the number of skeletons in whole numbers. 0.5 skeletons doesn't make much sense, does it? And then we're going to say int num humans. Now notice I didn't initialize this, right? I didn't say equals something. That's because we're going to use cin to give it the value. As long as we do cin before we use it, it's going to be fine. So here's our cout statement, cout skeletons versus humans, blah, blah, blah. I'm actually going to do two new lines, so I have an extra space. So now let's get the number of skeletons. Actually, we'll start with getting the number of humans. Okay, so we're going to say cout enter the number of humans, and I'm going to do colon space, and I'm not going to use a new line, so you enter the number on the same line. I think it looks better that way. So then we'll do cin num humans. Remember, this is how we get an input from the user. The program is going to wait right here, and then it's going to get the number of humans from the user when he presses enter. So next, we need to get the number of skeletons. So we're going to say cout enter the number of skeletons. And then we're going to do cin num skeletons. Now if I'm going too fast, feel free to pause the video. I'm just trying to get this done kind of quickly. Okay, so now we have the number of humans and the number of skeletons. So now we can actually make them face off. So remember in the hints I said we need a while loop. Well, if we have like 1,000,000 skeletons and 1,000,000 humans, right, we need to exhaust that loop. We need to keep looping until all of one of the armies are dead. So here's our while. Okay, and then here's the body of the while loop. And as you know, I like to have it backed up on the same line, but you don't have to. Now, what's our condition going to be? Well, we want to keep going until one of the armies is dead. Okay, so what we're going to do is we're going to chain together two Boolean expressions. I'm going to say while num humans is greater than 0 and num skeletons is greater than 0. So both of these have to be true, and you'll notice I put parentheses in here. You don't have to do that. I just like to do it because I think it makes it look a little better, and it's a little safer too, because then you know this is going to happen before you get the and. But anyways, the way this works is both of these have to be true, or it's going to stop doing the while loop. So if num humans is 100 and num skeletons is 100, both of these are true, so it's going to keep going. But if num humans is 100 and num skeletons is 0, then we're done because all of the skeletons are dead, so we don't need to do the simulation anymore unless we want the humans to fight air. Alright, so now, how are we going to determine who goes first? Well, I'm just going to say humans always go first, and what I'm going to do is I'm going to keep track of whose turn it is, and the turn is going to be stored in a char. You can do it however you want, but I'm going to say char turn equals H. Now remember, for a char you use single quotes, not double quotes, and a char stores a letter. So this capital H stands for human. So this is how I know it's the human's turn. Since I initialized it to H, that means humans are going first. So we're going to say down here, if turn is equal to H. So this is the human's turn. So we'll say right here, human's turn. Now, what about the skeleton's turn? Well, if it's not equal to H, then it's going to be equal to S. So we could say else if turn is equal to S, but since there's only two types, there's only H and S, we're just going to say else. Because remember, else happens if this doesn't happen. And if turn isn't H, we're going to assume turn is equal to S. Now, if you have multiple armies, say you want to have 3 armies all fight each other, you want to do something super complicated, then you'll probably want to do an else if with that army and then another else if with whichever army. But since we're just doing 2 armies, this is going to be really simple. Okay, so what do we do here? First, we need to get the chance of an attack, right? We're going to say the first skeleton is going to attack the first human. Well, actually, in this case, the first human is going to attack the first skeleton. So remember, how do we get random number generators? Well, we need to include something at the top here. We need to pound include random. So here's our random number generator. And then how do we get our random number generator engine? We say default underscore random underscore engine, and I'm going to call mine random engine. Okay, and then remember, what I forgot to do in my example is we need to seed it. So what we need to do is include time, or sorry, C time. And then right here, we're going to say time null. There we go. So now we seed it with time, so it's going to be different each time. And then we also need a range for our attack. So if we want 0.6 to be 60% chance and we want 0.2 to be 20% chance, then what we want to do is whenever we do an attack, we want to generate a number between 0 and 1. So remember, to get that range, we type uniform real distribution. And since this is a floating point number, we're going to put float here. And then we're going to call it attack. At least that's what I'm going to call it. And then for our range, we're going to say 0.0f to 1.0f. So the minimum is 0, the maximum is 1. Okay, so this is how we're going to simulate our attack. So let's go ahead and simulate the attack down here. First, we need a variable to store the output of this attack. So we're going to say, we'll put another variable here. We'll say float attack result. So this is the results of the attack. So we're going to say here, attack result equals, now we need to use our random number generator to generate a number. So we're going to say attack, and then in parentheses we say which engine we're using. So we're going to say random generator. So here we go. Now attack result is going to, did I do something wrong up here? Random engine, not random generator. So attack result equals attack random engine. So now there's going to be a number between 0 and 1 in this variable. So we need to determine if that was a hit. Okay, so first let's put a comment here, get our attack result. Then check if attack was successful. So to do that, what we need to do is use an if statement. We need to check this attack result. Since it's the human's turn, we need to check it against the human's attack chance, the chance that he hits. Okay, so what we're going to do is use an if statement. Excuse me. If attack result is less than or equal to human attack. So if the number is 0.6 or less, it's going to be a successful attack, and that is a 60% chance. So if that happens, we need to damage the first skeleton with human damage. However, all we have right now is the maximum health of a skeleton. We aren't storing the health of the skeleton in front. Remember, we have a bunch of skeletons here. All of them have 100 health. The one at the front needs to have his own unique health from the other. So if he gets attacked for 50 damage, now he has 50 health. If he gets attacked for 50 damage again, now he has 0 health, so he's going to disappear. That's what we need to do. So we need a new variable. So we're going to have a new variable for each human and skeleton, and we're going to say float current human health. So this is the health of the current human, and we're going to go ahead and start it out at the same variable that human health is, right? Because we're going to start it out at the max health. So we're going to say equals human health, which is the same as saying equals 250, but it's much easier to do it this way so that if you change this, you won't have to change it down here. And now we need to do the same thing for the skeleton. Float current skeleton health equals skeleton health. So now we have the health of the human that's in the front of the line and the skeleton that's in the front of the line. So what we do here is we damage the skeleton. So current skeleton, which is the skeleton at the front, health, minus equals, remember minus equals is the same as saying current skeleton health equals current skeleton health minus something. We're going to say minus equals human damage. Okay, so the skeleton was just damaged. Now, what about if the skeleton died? What if his health is now less than 0? That's what it means when he died, is when his health is less than 0. So we're going to use an if statement. If current skeleton health is less than 0, that means the skeleton died. So we're going to decrement the number of skeletons. We're going to say num skeletons minus minus. Remember, that takes num skeletons and sets it equal to num skeletons minus 1. So it's like subtracting 1 from the number of skeletons we have left. And now, since a new skeleton is at the front of the line, we need to set current skeleton health back to the maximum health, which is skeleton health. A better name for this skeleton health variable might have been max skeleton health or something, but this is fine. This is working okay. So now, last but not least, it's not the human's turn anymore, it's the skeleton's turn. So here at the bottom, we need to say turn equals S. So that's going to switch turns. So what's going to happen is it's going to start out with human's turn, and we're going to start in this while loop, and of course we have humans and skeletons, so it's not going to end. And we're going to come to this if statement. If turn is equal to human, right? which it is because that's what we started at. So we're going to do our first attack from the human. We're going to get an attack result. We're going to check if he hit. Then we're going to damage a skeleton and perhaps even kill a skeleton if only if we hit, right? We only damage the skeleton if we hit. That's why it's inside this if statement. And then at the end of our turn here, right before the else, we're going to set the turn equal to s. So now it's the skeleton's turn. So we're going to skip over this else because this if happened, right? The else only happens if this if doesn't happen. That's how if else works. So we're going to skip over this, right? And we're going to reach the end of our while loop. And since there's still humans and skeletons left, we're going to come back up to the top and we're going to simulate it again. Except now turn is not equal to h, turn is equal to s. So this is false, and we're going to hit the else statement. So now we simulate the skeleton's attack. So we do pretty much the same thing as up here. We can actually copy paste this attack result right here. And in fact, since we're copy pasting this attack result thing from this for loop to this for loop, it means it doesn't matter if we take it and just take it out of the for loop. It's going to save us 2 lines of code because we have to do this either way, don't we? Both the humans and the skeletons have to roll the attack dice. So we can just take it out, and now both of them are rolling the attack dice with the same piece of code. All of the other stuff does need to stay inside though. So now we say if attack result is less than or equal to skeleton attack, since the skeleton is attacking, that means the skeleton hit. So we're going to say current human health minus equals skeleton damage. Next, we need to check if the human died. So if current human health is less than 0, then num humans minus minus. Notice it's just the exact opposite of this one right here. Super simple. And then we're going to set current human health back up to the maximum health because a new human has run to the front of the line. So human health here. And that's it for our for loop. This is going to simulate the combat. Very, very simply, it's just going to keep going until one of these is not true. So if the humans win, eventually skeletons is going to become 0 because this right here is going to keep subtracting 1. And after that's done, this while loop is going to terminate, and then we need to print our results. So how do we know which army won? Well, that's actually pretty simple. We just see which army has people left. So if num humans is greater than 0, so if there's any humans still alive, then we say cout humans won, yay, and I'm going to put a /n right here. That /n, remember, is a new line. This is just going to make it look pretty. I'm going to kind of space it out. Let's also put some fancy cout statements like I was doing before. Let's do a cout /n beginning combat !n/n. You don't have to do this. I just like to do it. And then we'll do cout right here. Let's do a /n battle is over !n. And we can just do another /n here and get rid of this one. Honestly, it doesn't matter. This is just output. I just like to make it look a certain way. So we're going to say cout humans won and then a new line. Now we need to print the results. We need to say how many humans are left. So let's say cout there are, and then we're going to say num humans left. Okay? And that's just going to tell us how many are left. And we know there's 0 skeletons left since the humans won, semicolon. So what else should we do? We should do an else statement, right? And we should say, well, what if the skeletons won? Well, we can actually just copy paste this and change the word humans to skeletons. So skeletons won. There are num skeletons left. So this is if num humans is not greater than 0, that means there's no humans left, and we know that there's skeletons left. We don't have to say else if skeletons are less than 0 because we are guaranteed that. We're just using our logic to be able to know that if we have no humans, then we know there had to be skeletons left. And with this code right here, it can't happen to where both of them become 0. Both humans and skeletons can't become 0 because we only do one attack per iteration of the while loop. Okay, so there are that many skeletons left. So let's run it so far and see what it does. Let's see if it works the way we would expect. Oh, and then don't remember a return 0 at the end for completeness and a system pause if you are using Visual Studio. System pause. Oh, actually it's all caps, I believe. System pause. There we go. So let's go ahead and run it. We're going to hit run our local Windows debugger. Okay, skeletons versus humans. Enter the number of humans. 100,000. Entered a number of skeletons. They're really weak. I'm going to go with 400,000. Beginning combat, battle is over. See, even though there was that many, it was finished pretty quick. So there are 399,999 skeletons left. One skeleton died. Well, that means we have a bug, surely. So I bet one of you guys probably saw the bug. The issue was we never switched the turn back to the humans, okay? So what happened was, whenever the human went first, he luckily killed a skeleton, and then he said, okay, now it's the skeleton's turn. Then, whenever the skeletons went, he never said, now it's humans' turn, so skeletons were always getting to go. Turn stayed S. So what we need to do is put turn equals H here at the end. Yay for bugs. So we can run that again, but first let's make our output a little prettier. Let's actually print out some stats. Let's see how many humans died and how many skeletons died. It'll be easier to see just how well our armies fared against each other if we do it that way. So right now, at this point, we don't remember how many skeletons we first typed in, right? We only know how many skeletons and humans are left. So we just need a new variable that holds on to that value. So we're going to say int start skeletons, and then an int start humans, and that'll keep track of how many humans and skeletons we had at the beginning. So whenever we do a cin humans, we're going to say right here, we're going to say start humans equals num humans, and then we're never going to change this start humans value. And then we're going to say start skeletons equals num skeletons. We're just going to use this value to be able to count how many of them died. So now down here at the bottom, we can print our stats, how many died. So we'll say cout, we'll start with humans. So how many humans died? Well, all we have to do is use subtraction. We say start humans minus num humans. So if we started with 1,000 humans and we have 1,000 humans now, that's going to be 0 because 0 humans died. But if we started with 1,000 humans and we have 0 humans now, then we know 1,000 humans died. So we're going to say that many humans and start skeletons minus num skeletons skeletons lost their lives. So that's how many died. Pretty simple stuff. So here is our completed product, our finished program, and I don't think there's any more bugs, but even I can make bugs in these simple games. So let's go ahead and hit local Windows debugger. If you have bugs, you never need to feel bad about yourself. Everybody gets bugs. You just got to learn how to solve the bugs more efficiently. You'll get much, much better at finding bugs and determining what causes bugs as you do this more and more. Okay, enter the number of humans. We're going to say 100,000 like before. And then enter the number of skeletons, 400,000. It needs to be a really big number. Beginning combat, battle is over. Humans won. So there are 80,000 humans left. 19,000 humans died and 400,000 skeletons died. See how weak my skeletons are? My skeletons are so weak. And then our printout statements are kind of ugly. So I'm going to actually put a new line somewhere. I wasn't paying attention. We want our new lines right here, I believe. Yes. If I could type, we're going to put a new line here. And then we're also going to put a new line here. Just to make it format a little better. So, was I going to do something else? I think this is the end of our program. I'm going to go ahead and make skeletons a little stronger because I'm disappointed by how weak they are. Let's go ahead and run that again. This program right here, I'm going to be putting the code online. Hopefully you were following along and typing with me. That's the best way. I don't recommend that you copy paste my code, but you can if you really want to. So enter the number of humans, 100,000. Enter the number of skeletons, 400,000. Beginning combat, battle's over. There we go. A lot more humans died that time, but the skeletons still got destroyed completely. Let me zoom in case you can't see that. We typed in 100,000 humans, 400,000 skeletons. Beginning combat, battle over. 61,000 humans are left. Humans won. And a lot of skeletons died because my skeletons are so pitiful, it's not even funny. So guys, this has been our first challenge episode. The next challenge episodes are actually going to be real games. This is just the first episode, so I wanted it to be fairly simple, but I still wanted it to relate to games. Now I want you to go ahead and grab this code offline or off the internet. Or if you typed along, just hold on to it, because what we're going to be doing over the next few tutorials is taking this code and making it prettier. Now, as you can see, this main function is really massive, right? It's not, it doesn't look very good. Like, what if we want, a bunch of different monsters? If we wanted to have a new monster, we would basically have to make 4 new variables, or maybe even more new variables based on how complicated this was. And then eventually we're gonna have so many variables, it's just gonna look so stupid. It's just gonna be so hard to read. It's gonna be so hard to manage. That's not what you want to do. So instead, what we're gonna do is learn some new things called using functions and classes, and we're going to make all this code look much better. And while we're doing it, we'll probably maybe enhance this a little bit. So be sure to get this code and hold on to it, and stay tuned for the next episode. Thanks for joining me in the first challenge episode.